everyone. Today we have our another new episode and we will discuss on Industry 4.0. We have our world famous speaker, Mr. Eric, Mr. Adam, and Professor David Smith. First, I would like to give chance Mr. Eric.
Sure, Industry 4.0. Well, I'm sure that David will give us some really detailed stuff, but I like to take a step back and say, what does this thing feel like? And what the Industry 4 feels like is a massive change and disruption paired with opportunity. So that's really it is. It's really a balance between how are we going to disrupt ourselves and what are we going to do about it. And of course, there are going to be some big winners. And hopefully over time, it makes our life better. And when you look at the industry, industry came from let's make stuff, let's combine stuff, let's add energy to it, let's add motors, and then electricity was a big thing. Then it was like, okay, now let's deal with information and integrate computers into stuff. And now we're using geophysical systems and controlling whole things. And now we're saying that the basically technology framework can actually start making decisions and doing things like that. So there's the change. It changes the way we think in terms of information and communications is all changing. Our cyber physical systems, the way that computers and real world interact with each other. Our partner networks actually are changing. And if you don't believe that, just take a look at Amazon. It's just one simple thing, but it goes way beyond that for logistics change and all that. And the big thing is that means that our workforce is going to have to change. So, where are these opportunities? Well, they're obviously in the physical world. They're now also way in the digital world, but something that people often don't think about or focus on in Industry 4.0 is the biological world. So biology can change a lot. Just look at the Human Genome Project one, but biology, physical, digital, biological. So those are the opportunities. What I've seen a lot of talk about in the Industry 4.0 is, okay, so what do we do with this? How does this make the world a better place? So if we've got this change and this opportunity, technology, disruptive technology, driving change, creating opportunity. Well, it's that idea of corporate social responsibility. How does this change our society, our environment, our governance? I think governance is going to be a huge thing in there, which brings us on to the big thing that disruption gives us, which is the idea of resilience. How do you take these changes that are coming, all that? You have to train your whole workforce and your economies to be able to do resilience. Everything from, economic risk, sociological, social culture, IT, political, legal risks. For example, if you're dealing with tokens and crypto right now, there's a lot of legal risk coming on that. So that's the resilience, and above resilience is this idea of this long-term sustainability. How do you not only take a punch from a disruptive change, but how do you keep doing that over and over? That really affects things like competitiveness and future visibility, your organization and production. How do you fit your organization with what you need to make? And really employer qualifications and acceptance, who do you hire, how you do that. So if we get this idea of massive change, opportunity, corporate social responsibility, making the world better, being able to be resilient and sustainable, at the center of all that is, how are we going to learn and change? And I could go on equally long for education 4.0 and maybe talk about that next round. But to me, that's kind of how I look at Industry 4.0, is this balance between change and opportunity, change driving that opportunity, driving how we're trying to make the world a better place, being resilient and sustainable. And at the core of that is, how are we going to learn and train? That's a lot different. So with that, I'll turn it over as a round one thoughts.
Mr. Adam.
Thanks, Sharif. Well, Industry 4.0, this fourth industrial revolution is an event where there is probably no stopping it now. We're on the cusp, so it's inevitable, really, that we're going to go through this doorway into a new age. It could cause a traumatic in the way we live and work, and not only work, but it will our brains. Take the internet, for instance. That's already changed our brains.
Adam, your microphone connection's either loose or something. We're getting a lot of static through your line.
Boy. Okay, how's that? Better or not?
Better.
Okay, cool. Sorry about that. Yeah. Our brains have been changed in ways that make current generations as neurology and neurophysiology different to those of their parents and grandparents and other generations that didn't grow up with all this. I think this could be the first time in our history, where technological progress will develop so fast that we will struggle to keep up. So will that leave us no choice but to merge with these technologies using something like Neuralink? And what's going to happen to those of a more Luddite disposition and refuseniks who want no part of this smart civilization? It's said that they will be left behind, but can they be left behind in peace and be left in peace? There will always be people like that going all the way back to the Luddites in the 18th century and then the classic industrial revolution in the 19th century. Thank you. Those are my opening thoughts. I'll try and fix this connection. Thank you.
Smith, I think you're up.
Okay, looks like Sharif is frozen. Yeah, the industry 4.0 is a great little term to begin to look at and put some definitions around. We began to look at the different definitions and they vary from being focused on manufacturing to the one I like. It's the 21st century convergence of digital, physical, and biotechnologies to drive an unrelenting acceleration of human progress. And it's really becoming very well understood in industry and others. A recent survey said that almost 80% of global IT leaders say that the next 5 years will see a century's worth of technology advancement. Most of this attributed to the whole Industry 4.0 going forward and how it's going to put its pieces together. And part of our challenge right now is how to put together networks and systems that will actually begin to be able to handle this rapid and change, not only to technologies, but also what's it going to do to industry? What is it going to do to societal patterns that have been talked about? And how is it going to change our processes as we begin to look at this interconnectedness just exploding from edge of cloud to IoT to smart automation to autonomous systems, and begin to go back. But it really is ushering in a new way of doing business through adoption of digital platforms that drive new business models. And Industry 4.0 will see new business models coming in from everywhere as we begin to see this fusion of these different technologies put in together. And it really promises a whole new industry revolution that begins to look at what we're doing and where we're going. As you can see from the slide, we've started out with really a mechanical one with water power, steam. We moved to mass productions. Assembly lines became really popular. Industry 2.0 was all about assembly lines, beginning to move away from water and steam into electricity, and actually at that time also into pneumatics and compressed air and things to do the jobs. The third industry revolution was the computer revolution and how it dramatically changed our processes. But this fourth industry revolution is the cyber and the physical systems, the biosystems coming together to drive the future. So you can kind of see the progression as we've gone through the four industrial revolutions coming up to where we are today. And this is going to be a very interesting one, because each of these, when you go back, not just changed the technologies, but it changed the way society did business. It actually, each one of these began to change the regulations that industry worked underneath. And we're going to see very broad changes in the regulatory environment going forward under the fourth industrial revolution as well. So, Eric, I hope I gave you enough definitional elements from your start, but to me, this is where we're going, and it is totally very widely impacting all parts of society, like each of the prior three did. So, Sharif, introduction?
Thank you.
Something wrong.
Rob, I think it's you.
I think Sharif's having connection problems. What's kind of, for me, what's interesting is how rapidly the underlying concepts are changing in this idea of the fourth industrial revolution. When I first started hearing about this in the early 2000s, it was mostly about robotics and artificial intelligence. We didn't have the concept of the metaverse yet. And just recently, last week, I was briefed on the integration of artificial intelligence, robotics, and the metaverse. And the understanding is that you'll create digital twins of all the equipment, all the items that you have to interface with, and you'll begin interacting with them in the metaverse, not in the real environment. And robotics will step in and do the work. So if you identify a piece of equipment that needs maintenance, first, you'll be alerted wherever you are. You don't have to be at the factory. You can be any place in the world that there's an issue. The AI would make a recommendation as to what needs to be done with regard to correcting the issue, and it could be a series of selections, everything from lubricating it to replacing it. And then you would select what kind of reminds me of the old George Jetson's cartoon of just you have one button to push, but you pick the remediation method that you felt was most viable given the situation, and a robot of some type of automated service would go in and make the correction. And you'd observe the entire thing, not through cameras, but through its digital twin. And the digital twin is fully instrumented against the actual item. So you are seeing more through the digital twin than you'd ever see through a camera, because the sensors can detect things that you can't see. And the end result is you can act on a problem far more quickly. You don't have to have remote technicians or mobile technicians to go to the site and work on the equipment, because you have automated systems that take care of that for you. And the end result is you can have entire factories. In fact, if you've been watching the NVIDIA Omniverse stuff and that big BMW factory that was created with it, to a large extent, there are no people in that factory, or ever fewer people in that factory now. Robots are moving everything around, with the goal of having a factory be kind of like a huge 3D printer. And of course, we've got 3D printers coming as well. And so you get the situation where at some particular point in the future, you have raw materials going in one side of the factory and finished goods coming out the other. Now, granted, you'd optimize. There undoubtedly be factories that can build certain types of parts in volume much more cheaply than you can using 3D printing inside a factory. But with transport costs being high and transport and logistics risks being problematic over the last couple of days, if you're not speaking, could you mute? There's a lot of side notes coming through, and I think I'm speaking to you, David. But one of you's got a lot of hissing coming through on your line.
I think it's
anyway,
Sharif.
so that could be Sharif. Yeah. So who looks like he's frozen again with not the best expression on his face. Anyway, you have this concept of a well-instrumented virtual world tied tightly to the real world, and you're interfacing with the virtual world, which in turn is interfacing with the real world. and you're seeing through sensors, you're not seeing through cameras, but it looks the same to you. And then of course, increasingly, as we're looking at this, if all you're doing is choosing between 1, 2, 3, or 4 options, seems to me an AI could do that pretty easily too. It's just a matter of training it, and certainly a lot easier to train it on the 4 options than it would be to initially train it on doing the remediation. So it really does imply that we're on a hell bent for leather path of full automation and removing people from the equation entirely. That I'm not convinced is going to have the greatest outcome for us, because people do need to work and earn an income. Otherwise, who's going to buy the goods? You have large automated factories, no people working in them. We're going to have issues. So that in terms of income and purchase and economy, undoubtedly we'll work through that. And what I'm talking about, it's going to take decades to create. So it's not like we're going to wake up tomorrow and suddenly we're all going to be jobless. Most of us on this call will probably be just fine for the rest of our careers. But the fact of the matter is that's where we're headed, and it's fluid. I think we're probably not going to have a clear handle on what the 4th industrial revolution is until after the 4th industrial revolution is over, and we're talking about the 5th, because so much of what we're dealing with right now is just very fluid in terms of technology and concepts, and how you're going to implement it. The underlying concept of factory-sized 3D printers, for instance, is something we weren't talking about 15 years ago. And this melding of the virtual with the real, we were hovering around virtual reality and augmented reality a couple decades ago, but we weren't talking about this very tight integration, and we certainly were just beginning to talk about digital twins. But as we talked about them, we weren't really yet talking about how we were going to maintain consistency between the digital twin and its physical counterpart, and now we are. So we're really talking about melding the virtual with the real and making them not only somewhat indistinguishable from each other, but where the virtual is actually conveying more information than the real is by a substantial margin. So that virtual environment will convey far more information than if you were there physically, because that when you're viewing it virtually, you're viewing it through an ever-increasing host of sensors, and those sensors will provide you with information and intelligence that you otherwise wouldn't have. And of course, this opens up a huge potential can of worms, because what if somebody was able to intercept the signal between that factory and the operators and change what the operators were seeing, or if it's an AI, change what the AI was seeing, basically corrupting the data stream. Then you've got automation or robotics working against themselves, and a high probability the factory could be taken down to its knees, and you'd have some type of a catastrophic outage. So security becomes preeminent, and of course that brings in quantum. The underlying benefits of quantum technology, one of them is to be able to secure a data stream, because the one aspect of quantum computing that lends itself to security most directly is the aspect of observance, where if you can determine if a data stream that is otherwise unobserved becomes observed, the operator can tell it's been observed, and so it's likely been compromised. That's on top of quantum encryption, because if you've got quantum encryption, there's always the potential of having quantum decryption and being able to break the stream. But if the stream is being compromised, then you've got a problem, and then you can work to mitigate. So all of these technologies are flowing through pretty much at the same time, and I think this is somewhat unprecedented. The level of technological change we are about to experience over the next couple of decades, because we're not talking about individual technologies operating. We're talking about the combination, the collection of these technologies operating in concert, and increasingly the people that are going to be in high demand are those people that are cross-discipline. Those folks can figure out how to take a quantum stream and apply it to a manufacturing site. Those that can figure out how to take a visual element, a visual technology, the metaverse, and apply it to a physical technology like a factory. So they have to understand both factory robotics, and you've got to understand the metaverse, because you've got to be able to bridge the two to create a solution. And then, of course, finally, a deep understanding of artificial intelligence, and probably both synthesized data and deep learning, so you can roll the solution relatively quickly without the huge training costs that we're currently experiencing with deep learning machines at the moment. So it's going to be interesting with a huge increasing problem of data corruption and malware coming through this overall experience and creating what could be some serious long-term problems if we don't aggressively get ahead of the curve and make sure that securing these systems is on par with creating them, which isn't the case right now. Right now, our creation capability is vastly exceeding our secure capability. And in fact, often the firms doing the work are very different. The people that are creating the metaverse and the underlying links are not the same people that are working on securing them. And those two camps, at least at this moment, aren't really closely aligned at all. So there are going to be some interesting discoveries, both positive and negative, as we continue down this path, and something worthy of concern. But we are walking into a whole new world, and I'll tell you, I don't think we'll be able to really tell the full nature of this fourth industrial revolution until it's over and we start talking about the fifth. I think Hugh's up next.
Okay, thanks. Hi, Sheriff, Eric, Adam, Rod, and David. Hi.
Mr. Ching.
Yeah, I have spent a great deal working with Michael Rana on his fifth industrial revolution, Industry 5.0. Okay, obviously we have to look at what is Industry 4.0. His idea for 5.0 is to have a zero waste, no more waste. Okay, and I'm just a bystander, but we did go into it very, very deeply because he claimed to be the father of Industry 5.0. So, I'm not, I did not object to that, but only thing I want him to help to do is to calculate why is zero waste increase value. Okay, the last step in a process usually is the most costly, and I tried to get him to look into that. He did not really do that. See, and I think he might be very, very successful doing Industry 5.0. So in that, everyone has already talked a great deal about Industry 4.0, and I agree. I am particularly interested in Rob's talk because he started to look into some difficulty with Industry 4.0. Okay, it's actually started about 7 years ago, Industry 4.0, and it was started by a German. And the organization is World Economic Forum, which is pretty much us, economic talent at World Talent Economic Forum. Okay, so and I just want to give some basic feeling because I do have spent lots of time thinking about this whole thing. So basically, what I'm thinking is this: is it also another view of Industry 4.0 is for engineers to take over the society. Okay, I will correct that by saying for knowledge people with engineering background to work on the future projects. So I will inject knowledge. Okay, and that pretty much summarizes 4.0. In my opinion. Now I start to criticize this. You see, all these things people talk about up to now, okay, society interest in speed, size, precision in computer. Okay, computer represent automation as the most important of all the progress, but I disagree. I think complete automation is the most important. It will allow everyone participate in the progress. especially in complete automation software, which will allow anyone 6 to 60 to program a computer without any technical barrier. They can program in their own native language. So also again, I want valuation to become part of this part of this progress. They somehow people try to skip this idea of valuation. And also they skip the idea of complete automation, not just automation, complete automation. Something really strange happens when you have complete automation. See, complete automation is the solution to unlimited complexity, such as life. Okay? Life is an unsolvable problem. It's so complex. And in order to, also life is a permanent, satisfy the requirement of permanence. So we need complete automation to solve the problem of permanent existence. Okay, today all the invention, all the products have finite lifetime. And the valuation is, for some reason, people like to skip valuation. And the way, by Kenneth Arrow, Gerald Wu, John von Neumann, they think we need to consider all the future expectation in valuation. And that means we have to take the calculator to infinity. And that was, people refuse to look at infinity or permanence. I wrote a patent, which it could be the first patent which include the word infinite. Okay, quantitative supply demand model based on the infinite spreadsheet. And the supervisor of the title examiner just completely refused to let the patent even be reviewed because the word infinity. If you go into patent application, you see in the pamphlet they say anybody with permanence or infinity should not apply for patent. Okay, so I just, I have to use this term infinite spreadsheet. And finally, the director, Joseph Roller, came out and just dismissed the supervisor almost got fired. And finally, the Joseph Roller, the director, came out, say, okay, let's argue this. So I spent lots of time and effort in doing this. Finally, the patent was accepted. So valuation involved this infinity, and the permanence is solved by complete automation. So Industry 4.0 has a very big problem. Okay, like Rob mentioned many things that he thinks is should be correct in Industry 4.0. That's one major problem is it's starting by a German, and in Germany it's being promoted and standardized. Germans try to standardize this. Also, Japanese might also try, but still you can find the standard for 4.0 in some of the German companies. And I'm very much against this idea of standardization. Okay, I'm here in Silicon Valley. I'm US, is the land of free. Okay, they this standardization, there's certain things like software, Microsoft control standardizing, that is impeding the progress software. Okay, and here, we have industry 4.0 being standardized. Obviously, it helps because all this web, transfer information through the web is complex. So if you have a standard method, some small company can follow. But still, this principle standardizing reflect a culture. Okay, that is, in my opinion, backward. In other words, I'm here talking about the culture in Germany being backward compared to that in USA. Okay, they do not see this spirit of freedom. Okay, here in Silicon Valley, Elon Musk, one person can overtake the whole industry 4.0. Okay, he doesn't need this thing. He's very in favor of Germany. He loves Germany. So but people have this freedom, no standardization, open source. You see, all these things are in a more advanced culture. Okay, they all both belong to the scientific culture, but one is much higher in culture than the other. So that is basically the main objection I have after looking over this thing for such a long time. And that's my major question. It's such a complex situation. I guess you people can probably have more to say than what I have. Okay, thank you. I guess back to Eric.
Yeah, so I like David's drawing slide that he shared, which is pretty much what I was talking about too. And it's this progression as we move up to more technology, tighter integration. But the two things that a lot of those had in there was to make the really big changes. There's a lot of heavy government control, and the change came compared to today's standards pretty slowly. So one of the big factors is how do we accept change? And in general, most of us don't like change very well. I think people on this live stream probably like change, but that's not most people. We're unusual into that. And so the real question is, how do you deal with change? When I started, I remember corporations doing 5, 10, 20, 30-year plans. The government liked to have 5-year plans where here's how we're going to maintain this system for 10, 20 years. I remember arguing with somebody who, saying, hey, we could maintain these computers for 10 years. I'm like, are you crazy? Why would you want to do that? So, just getting companies to think about, 1, 2, 3 years ahead was a big change. To think about, well, there's this thing called web services, thin clients, VR, AI. It's tough, but what's happening now is change is kind of the order of the day. So how do you train groups and change the culture to make change part of what you do every day and make everybody in an organization a change agent, which means, instead of you go learn something every day as a learning experience, you have to break up the learning in chunks because, now you have this customized path as people are learning different things. It's not like you can just say, here's your VR degree, go out and you're set. Because even if you hit the road with that, once you start, things are changing fast. So we're talking about tailor-made learning paths where people go to learn all the things you need to know because we don't even know what that is. Also about it, at that point, then, instructors in universities and even AA become more mentors. Hey, look at this. How about that? Whereas it becomes more of how do you teach people to constantly look what's out there and solve problems by integrating it, along with the traditional thing of how do you do the new things. So you spend lots of money and effort to do quantum computing and learn that. But on the other hand, as people come up with new things, how do you implement them? For example, when you do the AI and basically computer-based intelligence, there's so many algorithms coming and changing so fast that we could all be creating algorithms. And the problem is, how do you find the new things, add to it, delete it, integrate it? So this idea of, in this era of change, how do we become comfortable with change at all levels of an organization together? And how do we constantly look at what's happening, what else is changing, and put it together to create new solutions? So I think we're going to solutions-based as opposed to, technology or standard based. So we need to do that to adapt quickly. And the other challenge of that is as you make these big changes, a lot of these big changes come from big organizations, and you're starting to see corporations do that. I mean, Facebook and Amazon and um, even the media like Disney and Netflix, they're starting to become these big organizations, and a lot of this change has been done with big organized control. And there's a pushback to that, and that's the idea of decentralization. So on one hand, we have trying to people organizing these huge multi-sided ecosystem platforms that control everything, and on the other hand, you're having people say, no, we can do this on our own and loosely integrate. So kind of summing up, what I would say is the big challenge today, and I think everybody brought up a piece of that, is how do we prepare ourselves to live and be comfortable when change happens? Second of all, how do we decide what to do with change as it impacts more and more of us effectively? Do you have big government do that? Yeah, there'll be that. But there's also a lot of decentralized people going, we're going to do our own thing and get as much independence as we can from those big ecosystems and government organizations. So those are two factors that I think are weighing. Adam, what are your thoughts?
Thank you very much. Oops, headphones. So two of the topics I'm particularly interested in regarding this topic are privacy and automation. In fact, I have been thinking a lot about privacy recently and the future of privacy, because smart cities and tracking and tracing potentially each individual within its population is a prospect that quite understandably makes many people nervous. This issue reminded me of a video game called Deus Ex for the PlayStation 2, a sci-fi cyberpunk video game, one of my favorites, and unanimously thought to be one of the best video games ever made. In one scene, the main character has a discussion with an artificial intelligence about surveillance and knowing everything about people. This AI says to the main character, humans feel pleasure when they are being watched. They want to be seen by another or by others, and even want to be judged by others so that they can be part of something larger than themselves. And it goes on to say that this was a desire, a characteristic first satisfied by God or the idea of God, then it was fame, and in the future or near future it will be satisfied by being data mined and stored and thus becoming part of this interconnected network. It got me thinking, I don't particularly mind too much taking photographs and checking in my location so that my friends and family know where I am or where I'm going, because I've nothing to hide and nothing to be ashamed about, and I quite like the idea of being part of this digital noosphere where I, and quite possibly everyone, is stored, thus keeping our existence, our memory, alive into a kind of digital immortality. It's the same fulfillment as people who write graffiti feel when saying, or writing rather, I was here. We want to go on and leave a legacy behind, and digital systems could make it easier for people to achieve that than before. And I'll probably talk about automation a bit in the next round. Thank you.
Hey, Adam, enjoyed what you said there and really what's working. The other thing I see as we talk about Industry 4.0 is like what Rob said earlier, is robots are going to be a really key component of Industry 4.0. And particularly as you look at them in the manufacturing role, in the transportation roles, in the Internet of Things as well. And really, machines do all the things as you go through here. And they need to share their knowledge increasingly in a complex sensor-driven role, which is what Industry 4.0 is going to really issue in. And, we're going to see the growth of more advanced things like 3D printers. We're going to see a next generation of CNC machines that are robotics oriented and are going to be some of the most versatile machines ever invented by human beings. Just the robots themselves, we're seeing them becoming more sensitive, more autonomous, more mobile, and easier to use, and really going through it. The other thing is we're seeing the digitalization being accelerated under Industry 4.0. We already know that the amount of data in the world is doubling every 2 years. We're going to see this really pick up even more speed. And as we extrapolate to production, this creates whole new production worlds. And as platforms become more available based on it, you're going to see autonomously optimized production processes and that you're going to see more and more lights out factories. And out factories will solve many of the human resource problems we have today in manufacturing. And you're going to see that being a good change. Um, we're also seeing, as we see what's happening across the big accounting firms and things, they are already seeing Industry 4.0 impact every area of society. You look at some like the recent EY report that says Industry 4.0 is going to change part of the gaming industry because the concepts we're seeing used in the industrial side, in the big data side, the robotic side, will have tremendous impacts in the gaming industry as well. Now, what are the impacts for the developing world? Industry 4.0 will provide the emphasis for changing approaches to manufacturing uh, and will allow some developing worlds the potential to leapfrog steps that are in the existing manufacturing domain to upgrade to all the automation that we're seeing. Also, by doing that, the training requirements are lessened for the basic manufacturing, but the ability to manage highly digitized systems, autonomous systems, machine vision, digital twins, and everything will increase. So, for developing nations, there's going to be a greater and greater need for more advanced practitioners in all those areas of engineering and data science and IT are going to continue to grow too. But just like we've seen in past industrial revolutions, each of them provides an inflection point for groups of society to leap over others. And we're going to see this going, I think, well forward with this. And the base industries will change. And as Rob had said earlier, it will have profound impacts because it's already started. And we'll see it, and it's going to have the tremendous impacts. But once again, I want to go back to one other point I made. It's not going to just change technology. It's not going to change our processes, but it's going to change our regulatory environment as well too. It's going to change how we certify and do things. And for it to have its true impact, we have to harmonize the regulatory changes globally, or we will have islands that cannot work with each other. So that's kind of my comments here. And I guess, Rob, it's you.
Hopefully Sharif will come back so we can end this thing when we're all done. So a couple things. He brought up the idea of a 360 economy, which is this idea when you build something, you refurbish, you either refurbish or remanufacture it when you're done. In other words, there's zero waste. And he introduced that as Industrial Revolution 5.0. And that's what I was kind of saying earlier about we may not know what's in 4.0 until we actually get to 5.0, because the underlying concepts of this 360 economy are being developed in parallel with everything else we've mentioned before. This idea of what you build, you'll recycle is now in plan for virtually every technology company, though the timeline varies from 2030 to 2050. That's the same timeline we're talking about for Industrial Revolution 4.0. So they're in parallel now. Weren't initially. It's a concept that we weren't talking about when we first started talking about the fourth industrial revolution, but it's now part and parcel of this underlying change. The market has demanded that companies be more socially responsible, and corporate responsibility efforts for every company that I cover have ramped significantly. HP and Dell, for instance, claim that they make individually something like $3.5 billion as extra revenue as a result of the corporate social responsibility efforts and their task for a 360 economy. A prototype you might want to look at is something called Concept Luna out of Dell. It's a joint project by Dell and Intel that I've been covering over the last few months. This is a personal computer that was completely redesigned with the idea of making it fully modular, fully recyclable, and a machine not only assembled, but a machine disassembled, so that you could, in some future point in time, you could take this machine and you could put it into a kiosk, and you'd get a credit back for whatever else you were going to buy, or it would get upgraded and passed back to you. The underlying benefits of this technology go beyond being able to keep it out of a landfill, because it also allows for a high degree of customization. It allows you to replace the components individually without having to replace the entire system. And this comes down to the issue with when you go to a modular effort, why standards are critical. The way of the computer world back when I first started in the 1980s with IBM was there were no real standards. Well, there weren't official standards per se. There were standards, but much of those early computers, the standards that they had were held by IBM. They were the standards holder. And so for instance, in storage, it was a little known fact that didn't matter who built the storage medium or the storage product, there were IBM components inside, and a significant number. Because IBM owned the patents, the intellectual property, and the manufacturing capacity for storage, and they were in effect the standards holder. Now, if we go to mobile, in the mobile world, we have non-essential patents that cover that essential and non-essential patents that cover that environment. That are dictated by government and controlled by government, which prevents any one company from controlling the environment as IBM once did and Apple tries to do. And what happens when you don't have standards is you get a concept called lock-in, where you buy from a particular vendor, but once you buy from them, you have to stay with that vendor long term, because you can't migrate. The cost of migration exceeds any benefit that you might get from the migration. And in the 1950s, the U.S. government said, "Yeah, IBM, you're not doing that anymore. You've got to open up your environment and be standards based." And it almost broke IBM. Same thing happened to Microsoft at the end of the 90s. The European Commission came in and said, Microsoft, you're not really going down the standards path. Interoperability isn't working for you. You will interoperate. And I met with the executive team at Microsoft at the time, and they were convinced that we'll interoperate, but we're going to charge those other companies an arm and a leg for access to those APIs and that interoperation capability. And I and others looked at them and said, "Do you really think the courts in Europe are that stupid?" And they changed that. To their credit, they changed their entire approach. Now they're heavily standards-based. They lead in interoperability, and they chase to be the most valuable company in the world as a result, which showcases that standards actually benefit everybody. Including the folks that get dragged kicking and streaming towards them, because they allow for competition, but they also force a company that's in the lead to remain competitive. And that really was kind of the big problem with a lot of the companies, is once they got to be dominant. Look at Microsoft with Internet Explorer, the operating system, or IBM with mainframes. Once they got to be dominant, they started to treat their products as cash cows. They stopped developing, they stopped innovating. Customers were locked in, so they didn't really have to worry about keeping customers happy because they couldn't move. An IBM executive at the time told me, "Rob, you don't get it. We here at IBM, we sell air, and customers have to pay whatever we charge them." My response was, "Yeah, they may do that now, but eventually they're going to figure this out and go to a different vendor," which they did. A few months later, it wasn't even years. A few months later, the market corrected. The IBM CEO was fired. Lou Gerstner was brought in, only CEO that's ever been fired in the history of the company, and somebody else was brought in. And now IBM is open source, hell bent for standards. We'll never go back to that closed, non-standard environment because it's a company killer. The end result is when you go down that particular path, yes, you can reach dominance, yes, you can lock in the customers, but it takes you down a path that gets you to treat those customers unreasonably, to take them for granted and make decisions that will invariably kill the firm. And that's why we've got these cycles of, you look back in history, the number of companies that were around 100 years ago that are still around today. I was at the 100-year anniversary for IBM, and they went down the list, and you'd have fingers left over after one hand, actually, for 100 years. And he said after 50 years, you'd have fingers left over after two hands. So the firms that were large, prominent when they were. This idea of interoperability, this idea of standards and allowing different companies to compete is actually very healthy for the environment, and assures we don't get the kinds of catastrophic collapses that we've historically had with IBM, almost had with Microsoft as well. And the firms that have embraced these standards, Qualcomm, of course, is a heavy believer and drives the cell phone environment. Intel, not so much. AMD more so. The ones that are much more focused on the customer and less focused on locking folks in and making sure that competition is healthy, as well as having a healthy product and an operation, have done just historically quite a bit better. At least over the last couple of decades, they've done quite a bit better. You go back before that, standards were quite a bit weaker outside of the electrical standards, which, if you look across the world, we pretty much sucked with regard to worldwide standards early on. The U.S. hasn't even figured out metric tools yet. Neither has England. We were supposed to all go over to metrics decades ago. But the lack of standardization, worldwide standardization, does create drag. It does slow down adoption. It slows down implementation. And in some cases, that slowdown is good because it allows some things to catch up. In other cases, it's bad because what it does is it shifts industries from countries that otherwise would get them to other countries that are much more aggressive in moving on the standards. It's the Asian countries, of course, have come up very rapidly against the U.S. And 100 years ago, the U.S. came up very rapidly against Europe, and now, of course, we're facing China replacing much of the Western world with regard to manufacturing. And the only thing that seems to be fighting that at the moment is China itself, which is just kind of bizarre for me to watch. If they just kind of kept their heads down and kept going, they'd own this market, but they want to prematurely take it over. And the end result is they brace themselves as a threat, and the rest of the world's fighting back, which is pretty unique historically in this regard. Otherwise, China would probably own worldwide manufacturing, and we'd be screwed if they decided to take that as a competitive edge and drive the world where they wanted to drive it. Fortunately, we do have balance. So with regard to the circular economy and with regard to standards, at least from my perspective, they've been very beneficial for the environment that we have it. Having been at IBM when they nearly collapsed as a result of their refusal to initially embrace open source and standards, and working with Microsoft when they almost collapsed, $3 billion a month fines. You don't survive that for long because they weren't embracing standards. And both companies, now that they've embraced standards, open source and platforms like Linux, are doing far better. So it kind of showcases that sometimes when you're cooperative and you interoperate, you can do far better. And this new future world is going to require it. There is no way you can do large scale equipment repurposing and refurbishing unless you have a high level of standardization. Otherwise, the cost of dismantling the equipment is simply too high. It's just cheaper to mine the materials than it is to get it back out of the equipment, unless you redesign that equipment so machines can take it apart and take out those core components and remanufacture them. That's really where the standardization effort now is becoming focused is, okay, you've got this big piece of complex equipment. How do you break it down so you get to the core elements that can be reused? And how can you do that cheaply and easily so that you can make it cheaper to recycle something than it is to create something from scratch? And in all cases, it should be cheaper to recycle something than it is to create it from scratch. It just at the moment it isn't, because we blend these things together in such a way that it makes it very difficult to take them apart. And that's why Concept Luna is so important. It showcases you can build things and make them price competitive and provide a series of advantages. But as I mentioned, when you go to a modular approach, you're going to have to standardize the modules. Otherwise, you don't get to the economies of scale that you need to make the overall project work. I was involved with the modular computer project out of the IBM PC company at the end of the 90s, and it was a brilliant project. The idea was you'd have a standard computing module, and that module could be your basis for your cell phone. Granted, the technology in there was pretty large. It was just shortly after IBM Simon, which was a brick of a smartphone, of course, never sold very well. But it made for a large smartphone. But you could use it in a desktop computer, tiny desktop computer, a laptop computer. You could use it as a module in your car. The concept was good, and that kept the module cost volume high. Volume high, and kept the overall individual cost low. But the problem was nobody else adopted the standard, and so you couldn't get to the kinds of volumes you needed to get to the price point that overcame the extra cost, coupled with the complexity of the modular approach. And so it didn't work. Even though IBM brought it out, they never brought it to market. A company out of, I think it was Sweden, eventually brought it to market, but it wasn't cost competitive, and it didn't survive. But had it survived, our entire computing environment would be very different today, and we'd already be much farther down this idea of a 360 economy than we currently are. So we're revisiting it now, and we are revisiting it with the idea of using common standards and working through it. I should point out there was one other company that attempted to do this. It was called the Panda Project. Early in 2000s, they came out with an idea of a passive backplane, which was really interesting. The idea was you'd have a passive backplane, and on that backplane, you put the chipset, you put everything was cards. Somewhat reminiscent of a decade or so earlier with the PC Junior, where everything was cartridges. So the market has been really trying to approach this modular concept of individual upgradability, but it's always failed because of the lack of standards at the modular level. And this time around, we're going to try to standardize the modules so we can get to the economies of scale we need and get it to stick. But it's going to be critical to get to that 360 economy, because if you can't inexpensively dismantle this stuff, you can't make the numbers work. It's got to be at least as cheap as building it originally, and ideally it needs to be cheaper, and then provide other benefits: high customization, high upgradability on an individual component. So if you have a laptop, you can just upgrade the screen. You don't have to replace the laptop if you want something different. Or if a new processor comes out or a new chipset comes out, you can replace those without having to replace the overall case, and creating all that extra waste that comes when you have to throw out an entire computer just because one component has become obsolete. So it's an interesting environment. This Industry 4.0 is going through massive amounts of change at the moment in terms of concept. The one thing that's clear that's going to be in it, of course, is artificial intelligence. The level of quantum computing inclusion is going to really depend on how fast that technology spins up. IBM just last week announced yet another quantum computer, still short of what we need for quantum supremacy, but much closer than we were, and still looking at perhaps having viable quantum computers before the end of the 2030s, which is a lot sooner than we originally thought. So that's moving in as well, which means we have a ton of flux here. And that still takes me back to my belief that until we really get through the fourth industrial revolution, we probably won't really know what will make it up, because it's so fluid. Every element is in motion. Interesting times.
Thank you. Mr. Ting.
It's interesting that Rob put some points into this standardization. So, by the way, this complete automated software, everyone can have his own standard. It means that you can have your own language, okay? Because everything is automated. You have auto updating, auto documentation, and self generation. Okay, made to have all the software generate software. So there is a possibility for completely get rid of, bypass the standardization process. In hardware, it's hard to do, but in software, it's already been patented. This patent done by me, and it was accepted immediately by a person by the name of Richard Ellis. Okay, I work in real estate. Richard Ellis is biggest company in real estate. So it's interesting. Also, I'm 4.0 should include valuation. And by the way, I'm working with the fourth generation Milton Friedman plan. Okay. And we try to work to dominate the valuation. And let's see which one goes faster. 4.0 is fourth generation. So Eric mentioned change. Okay, that's very interesting. Okay, the infinite special valuation is designed for change. The price depends on all the future expectations. So in other words, anytime the future expectation changes, the price need to be recalculated. And here, only God can make one plan and never need to recalculate. It just unfolds like the living system. Okay. However, all the billions of living things exist on Earth, only less than 1% survived. So in terms of fuzzy logic, the range of tolerance on Earth and the range of possibilities of creation only overlap less than 1% to form the range of survival. But that is enough in the absence of the creator. Okay. So all this change, things tested their ultimate form. I hope in that 4.0 never mentioned fuzzy logic. It didn't mention valuation, didn't mention complete automation. So I guess we have to wait. Also, we might have to do it ourselves. With continue Milton Friedman's legacy and try to really go out into the industry like engineers, try to make things work ourselves with young people. All this fourth generation, they're only 16, 17 years old. I think we have a very promising future in this direction. Okay, thank you, Dr. Sheriff.
Thank you. Thank you. Mr. Eric, what's your concluding remarks?
Well, we've talked about a lot about change and the ability to continually integrate change in our daily life. And of course, standards have a lot to do with that. And sometimes in the past, big companies have fought standards. So it's good to hear that more and more companies are going with open. It's kind of interesting in that I ran like 17 innovative events. And we never, while the government at that time was trying to specify a standard for everything, we actually didn't specify any standard at all. We just said you have to use one, pick it, and involving the big companies and small companies and government, industry, and academia together. We always found a way to make it work, which was pretty exciting. So I think a lot of this dealing with change is going to come from big people putting big resources to do the kind of work that Rob's talking about, which I think is fantastic. I think also a lot of time big companies don't like to move till they see a very definite return on investment. And small organizations tend to be willing to take those risks. Sometimes 1 to 5 people will go try something and take risks. So I think a lot of the advancements are going to become from small companies. But I also see the ability of organizations joining with other organizations, connecting things like in the book, The Network State, where a lot of these small decentralized groups come together for various purposes and do that. The other thing about dealing with change is David talked about robots. Our relationship with automation, especially robots, has a big change as our cultural feelings. For example, they have robot hotels in Japan, and the Japanese are more interested in the human computer interaction as an important part, and a lot of the other tourists are more integrated and interested in the functionality and technology. So as we start to look at robots become they look more normal to us, they feel normal, they talk normal, and our culture starts changing. That's going to be a big part of accepting change, is how we deal with this automation. So again, lots of expect a forecast of heavy duty change, expect the forecast of heavy duty opportunity. and challenges. Expect the need to deal with this change both on a global, big, large organizations and resources, and both on a decentralized coming together. And our relationship with change, especially when it comes to AI and robotics, is going to change along with it.
Thank you. Thank you. Mr. Rob, what's your concluding remarks?
Oh, to me already. Just recognize that the skills that this new environment is going to favor are going to be multi-level. I mean, multidisciplinary. The folks that we're going to need to bring this out are people that know engineering, computer science, and also know where it's going to be applied. So engineering, as it could be applied to manufacturing, as it could be applied to the metaverse, as it could be augmented with artificial intelligence. But each one of those specialties is going to require some knowledge to be able to implement the overall solution. And people that can bridge those knowledge areas are going to be in short supply and highly valued. Doctors in particular that also understand computer vision are going to be in high demand as we explore and advance in telemedicine, and as we start to introduce artificial intelligence into the surgical theater. Same thing with regard to automotive. As we move to artificial intelligence in cars and autonomous vehicles, we're going to need people that really understand not only how automobiles work, but how you would apply artificial intelligence to make them better. Right now, the AI guys and the car guys are still, for the most part, largely separate. But that's going to have to change rather dramatically over the last few years as we start rolling these things to market. So look for those bridge careers, those careers that cover two disciplinary areas. They're going to have to work together because those are the kinds of jobs that will be invaluable and will undoubtedly be in short supply for the foreseeable future. Also, it gives you a certain amount of breadth. The more breadth you've got, if one area declines, you'll have the other area to fall back on. I am not a fan right now, in particular, of tight specialties, because this environment is so fluid. Your specialty may become obsolete. So being as general as you can early on and being as multidisciplinary as you can when you exit the process, the more valuable you're going to be when you start building a career and advancing, and hopefully the less risk you'll have, most assuredly the less risk you'll have of becoming obsolescent prematurely. And that's my advice as we go into this new world.
Thank you. Mr. Ching, what's your concluding remarks?
I just have two points. Changing industry is not as important as raising the cultural standard. Okay. And the USA is the new world. It leads the world. Okay. And the young people, my advice to young people, they should try to build the next new world, not looking back into what is going on. Okay, yeah, thank you.
Thank you. Thank you. You know that World Talent Economy Forum, we are doing side open dialogue for COP27. So next 3 episodes, we do focus on the COP27. So I already sent invitations. So those who want to join in our COP27 dialogues, you can join. Thank you, Mr. Eric, Mr. Rob, and Mr. Ching for your continuous support for World Talent Economy Forum. Bye-bye.